Okay, guys. So what we're doing with this one is we're just going back to the probability. Remember what we talked about. We talked about this being that we're going to have the number of positive outcomes over the number of possible outcomes. Okay. And so that's really what we're going to do with this. We're going to talk about setting up as a proportion. Some of you will see that you can set it up as a percent and do your percent math with it, and that's fine. I just want to kind of review how you would do this using a proportion. Okay. Okay, so what you have to be careful of is what are they asking you for? Do they want the answer in a fraction? Do they want it in a percent? Do they want it in a decimal form? Okay. If they ask for it in a decimal form or in a fraction, you have to remember that your probability goes from 0, which is it's impossible to happen, to 1, which means it's certain it's going to happen. Nothing gets bigger than 1. So none of our answers should be bigger than 1. We might have like 89%, but that's 89 over 100. Okay. So when we look at this first question, it says spinner is divided into 8 sections, has 3 of them are colored white. What's the probability of it landing on white? Okay, well, that's simple. 3 of them are colored white. So again, we're talking about number of positive over the number of possible, right? Well, there's 8 possible. There's 8 sections. So that's going to go on the bottom. And there are 3 possible that are white. So our probability is going to be 3 over 8. Okay, and then if you want it, and that can't be reduced, and so that'd be 0.375, which is 37.5%. And if you rounded that to the nearest whole percent, that would be 38%. If you're going to use it, you want to keep it as accurate as possible. If they just ask you for that answer and they say round to the nearest whole, then round. But otherwise, I would not round if you wanted to have an accurate answer. Okay. So the next question says, well, if the spinner is spun 788 times, how many times would you expect it to land on white? Well, so we're just predicting, right? So we're going to take what we already know. So we already know this is the probability that it's going to land on white. So we're going to use that. We're going to say we have 3 over 8. Okay, and this is what we're given for our reference. Okay, and so that's our reference, and then we're going to do the actual. So what we're doing is we're really just doing a proportion that's part over whole, the positive over the possible, right? And so then what we need to do is look and say, well, this right here, this number right here, the spun 788 times, that's the total. That's the whole. So we're going to take that and put it down here, 788. And now we don't know this, so we don't know what the numerator is, so we're going to plug an x in there. Now we solve this. Now we've talked about how to do a proportion. So there's a number of ways. We could use scale factor by looking and saying, well, 8 times what would give me 788, and then multiplying 3 by that same number. But if we look at this, most of you have probably already realized you could just solve for the variable. So we could solve for this by multiplying both sides by 788, which is what some of you were thinking of doing anyway, because you were going to take 0.375 times 788, or 1/3 times 788. And so that comes out to be that it's 295.5. So we would say, we would expect it. So we're going to just put the words in, right? So we're going to say you would expect it to land on white 296 times. There you go. That's all we did. All we did was write it out, solve it as a proportion, and we used our reference, the 3/8. Okay, so what we have to remember with this is we're going to have the number of positive outcomes over the number of possible outcomes. All through, that's what probability is, okay? It says right here that what we did was roll 42 dice. And we're going to assume they say they're fair, right? And how many times did you expect to get a 3? Well, again, if we look at what are the possible outcomes, our possible outcomes, we have 42 possible outcomes because we rolled it 42 times. Okay. And let's look at the possible outcomes that we could have. We could have a 1, we could have a 2, we could have a 3, we could have a 4, we could have a 5, or we could have a 6. So there are 6 possible outcomes right here. These are our possible outcomes. So we could have 6. So we're going to set this proportion up. We're going to have over 6. And how many of these are 3? Well, 1 is not a 3, 2 is not a 3, 3 is a 3, 4 is not a 3, 5 is not a 3, 6 is not a 3. So we only said yes once, that 3 was a 3. So that's one positive outcome over the possible. We're going to say that's 1 over 6. And they want to know if you roll it 42 times, how many times can you expect to roll a 3? So we don't know this yet. We're going to solve that. Most of you have seen, when we've solved proportions, so when we look at this, we're going to probably just multiply both sides times 42. And we get that x is going to equal 1/6 of 42, because we would put this over 1 to multiply across, which means we'd have 42/6, which is 7. So we'd say we expect to roll a 3 7 times. That's our answer. So the next question is, how many times would you roll an even number? And that's the key right there, even number. And we just look at what we have. We have a 1. Is that an even number? No. Is 2 an even number? Yes. Is 3 an even number? No. Is 4 an even number? Yes. Is 5 an even number? No. Is 6 an even number? Yes. So our even numbers, there are 3 out of 6 are even. We have 6 total outcomes. 3 of those are even. And we want to know then how many times will we roll an even number out of 42. So again, we're going to run 42 over x. Well, now one way to do that, we already did solve for the equation, but when I look at this, I realize, well, 6 times 7 is 42, so x must be 3 times 7. And 3 times 7 is 21. So x equals 3 times 7, which that means x equals 21, and that was the number of positive outcomes, how many evens I would expect. So we would say you expect to roll an even number 21 times. And if we look, all we just did when we're answering this, all we did was say, here's what our question was. Then we answer it. Okay, as we look at this one, the first one says a bag contains, we have 21 blue marbles, 24 red marbles, and 15 pink marbles. If a marble is randomly selected from the bag, 420 times with replacement. That means you pull it out of the bag, put it back in. With replacement, how many times would you expect to select a red marble? We got to be careful. We got to make sure we're looking at the right ones. And maybe we want to color that like this so we can see there we're talking about two things. Well, so how many marbles do we have all together? We have 21 blue. We have 24 red. And we have 15 pink. We add those together, 21 and 40. 21 and 24 is 45 plus 15, there's 60 total. Okay, there's 60 total marbles. So again, if we're doing number, that's the number of possible. So our ratio is going to be over 60. And they want to know how many red marbles. So red, there are 24 red marbles. And they want to know out of 420 times. So that's going to be the number of possible outcomes. That's the total or the whole. So we're going to have 420. And we want to know how many red are we going to get. Well, so again, you can solve either using cross products. You could take it and multiply this times this and do the cross products and say 60R equals 24 times 420. Okay, that's going to be a lot of work. You could solve, which would give you almost the same result. But if I look, for me, I realize, well, 6 times 7 is 42. So I just got to figure out what 24 times 7 is, because 60 times 7 would be 420. So I just have to do 24 times 7. So that means R, the number of red marbles, is going to be 168. So my answer would be, you expect to select a red marble 168 times. And then again, if we're going to, so why don't you figure out, go ahead and I'm going to pause this for a minute. But now you figure out how long would it take you to select a pink marble. You're going to use the same proportions. You're still talking about the number of positive outcomes over the number of possible outcomes. You're setting up a proportion, solving that proportion. Okay, I'm going to just pause it right now, solve it, and come back in. And I'm just not even going to, I'm going to just not say anything for at least 30 seconds. So when you pause, when you're done, pull it up, see if we did the same thing, if we got the same answer. Okay, so you should have come out that you were going to get that 105 times. You were going to get the pink marble 105 times. So when I looked at this, again, we're setting up the same proportion. We're still talking about number of positive over number of possible. Only this time we're talking about the pink marbles. So we come over there, there's our pink marbles. There were 15 of them. So this changes. The numerator on our reference changes, but our denominator doesn't because our total is still 60. Our total number of times we tried is still 420. So the only thing, and then now we're trying to find how many pink. So if you look, our scale factors stayed the same. So all we really had to do is just change the numerator, which means we're going to take 15 times 7, and that's going to be 105. Okay, let's look at this one. Now again, we're just going to use a proportion. Our proportion is going to be the number of positive outcomes over the number of possible outcomes. And they tell us, we're just going to go through and kind of highlight, they tell us we're going to have 120 people are given drug Z for a treatment. And drug Z has a success rate of 65%. What is the expected number of participants who will be treated successfully? Okay, so again, if I'm looking at the number of positive over number of possible, then I'm given that it's 65%. So that means I'm going to have my reference ratio is going to be 65 over 100. And then I have 120 total people. So that's going to be the total, because this is part over whole. Okay, and then I need to find out how many were successful. So we'll put there for an S, okay? Okay, so just gonna do, if all else fails, if you just can't see the solution, then what you can do is you can use cross products, or what's called means and extremes. So you could say I'm gonna have 100 times S is going to equal 65 times 120. Okay, so I'm still going to have 100 times S, and this is going to be 7,800. Okay, when I multiply these together, I get 7,800. Then I'm just going to divide by 100 to solve for S. And I'm going to get that S equals 78. So my answer is, and again, I'm just looking at the problem here, expected number of participants who will be treated successfully. You expect 78 patients to be treated successfully. Remember, we talked about if you're asked a question in sentence form, you should answer it in sentence form. Okay, so really all we did, now some of you are going to say, oh, well, I could have done it a different way. And you could have. You could have just said, well, I'm going to take 120 times 0.65, which equals 78. And that's acceptable work. I just want you to be able to see you can do the basis. All of this comes from that proportion. So if all else fails, you can use the proportion. Because these numbers, sometimes when students do it this way, they don't quite know why they got numbers where they got them. And you can make a lot of errors. But if we know that we're talking about the number of possible, or number of positive over the number of possible, using this understanding, that's what probability is. Well, then you're set up every time. No matter how hard, you just put things in their right place. Okay, so let's look at this one. 500 transistors, there's a key number, right? 500 transistors were tested in a factory. 82 were found to be faulty. What's the experimental probability? In other words, what's the number of positive outcomes that will be faulty? Okay, so 82 were faulty. So we have our original proportion is that 82 out of 500. Okay, so that's our original proportion. So again, this right here, you're gonna put they're gonna want it reduced. So if you put that in the calculator, 82 n over d 500, it automatically takes that for you and says, well, this is going to be 41 over 250. There you go. There's your ratio, simplified. And then if you're going to put it, so we can either write it as a ratio, we can write it as a decimal, or we can write it as a percent. So why don't you figure those out, pause it, you figure what those are, and then we'll come back. Okay, so there's our 3 different ways to represent this. Remember, if we're talking about decimal, it should be between 0 and 1. Okay, now I would leave it this way until you, if that's all you had to do is come up with the probability and they say round to the nearest hundredth or round to the nearest whole percent, go ahead and use that. But right now what we're going to do, they want us to expand on this. So what they want us to do, we read here now, it says, if another 1,250 were tested, how many do you expect to be found faulty? So there's 2 ways to interpret this. We could see if we're just gonna test this, the 1,250, or we have to figure out, are they asking us for the total, the 1,250 plus the 500? I'm gonna assume it's the 1,250. I'm gonna go with the 1,250. Okay, so here's what I want you to do. You set this up. Pause it. You set the proportion up. See if you get it. If you get the right answer, after 30 seconds, you'll come back on, or after you're done with it. I'm going to leave for 30 seconds and just mute myself. Then when you come back, check and see if you got the right answer. Okay, let's look at this then. So again, if I'm looking, all I did was take the original proportion, set that over here, because I'm using that as my reference, right? They gave me that information. They tell me it's staying the same. And I know that I don't know how many I have that are faulty, but I know that my total is 1,250. And what I also know is that my scale factor from 250 to 1,250 is 5. So all I really had to do was say, well, if I had 41, 41 times 5 will be how many are faulty. Basically, that's 205. So my answer would be, I'm just going to take these words. You would expect to find 205 are faulty. Okay. So look that over. See if you understand what you did. I mean, there's probably a couple ways, but hey, just let me know what we can do. Okay, we look at this one. Again, it's a spinner, right? It's spun 20 times. How many times would you expect the arrow to land on the green? Well, what's the probability? What's the theoretical probability of it landing on green? Well, there are 4 equal-sized pieces, right? And this is just, green is just 1/4. So the theoretical probability of getting green is 1/4. So if I'm rolling it 20 times, then I'm going to set up my original is 1/4 equals x over 20. And I know that 4 times 5 is 20. So that means 1 times 5, which is 5. So I would expect you're going to have it land 5 times. It'll land on green 5 times. Okay, but then he takes it and says, so that was off a theoretical. He says he's finished spinning. You notice that the arrow fell on the green 11 times. Write the experimental probability. Well, so he spun it. Remember, we're still talking about number of positive. One of them that meets the criteria over the number of possible. Well, the number of possible were 20. And it did land on green 11 times. And 11's prime, and it doesn't go into 20. You're done. 11 out of 20 is the probability that he's gonna get green. That's the experimental. Now we know when we look at the original that the theoretical is 1/4. But when you spin it, you know what happens. If it's truly random, if you don't have more than 100 trials, that's a key number that I would have been teaching you. But if you don't have more than 100 trials where you've done it 100 times, you're not going to get close to random. You're going to have a lot of you are going to be off on your experimental probability. But as you increase your number of trials, your probability draws closer and closer to the theoretical probability. That's what we would have talked about this year. So the key to all of this is this right here. The number of positive outcomes over the number of possible outcomes. Everything builds off of that. You look at every problem, we set up a proportion. That's the key of this whole year. We talked about proportions. We set ourselves up so we could learn to solve an equation and with integers and then solve a proportion. Everything we've built off of after that has gone to ratios and proportions because next year that's going to be very important to you. Okay, hope this helped. Okay, if you're struggling, there's other videos available on YouTube. Do that. Send me an email. Let's work on it. Let's make sure you're being successful. Okay, talk to you later.